Hi, I'm Ben.
And I'm Sarah, and we're here with flightSnap, which is an application for birders to understand which birds they're most likely to see when they're out in the field.
So when we started out on this project, we were really excited about the idea of helping amateur birders and scientists alike understand which types of birds that they might encounter out in the wild and help them identify them and understand how those types of species relate to one another.
This can be a really challenging problem if you haven't seen certain species of birds before and you want to know which ones you're likely to see based on which birds you've already seen, as well as the time of day, the season, the habitat you're looking in, etc.
To do this, we used a combination of JavaScript, HTML, and a D3 library. Using eBird, which is an interactive online site run by the Cornell Lab of Ornithology, we were able to obtain data about a large set of bird sightings, and we took this data, we parsed it in JavaScript, and then we output it into our final D3 file for visualization.
In our last update, we integrated a sample set of data with our D3 visualization to provide a couple of different test visualizations using a standard chord diagram. However, when we integrated our full data set, we realized that it actually created visualizations that weren't particularly useful. All of the information overlapped and it was just too confusing to learn anything interesting. So what we've done since then is we've actually created a couple of new data sets that support better visualizations.
Originally, we had over 100 years of data from eBird, which contained a sighting of over 330 different species of bird in Massachusetts alone. When we filtered by the one most recent year, this cut our sample size down significantly, and it reduced the total number of species from 330 to about 280.
We first looked at patterns in the data divided by season, but what we realized is that there are actually more interesting patterns when we divided the data by months. In order to make our visualization the most useful to the end user, we decided to include all species of birds, regardless of whether they were seen in that particular month, so that we could discover different patterns between each month with different visualizations. After experimenting with a couple of different D3 outputs, we changed our visualization from a chord diagram to an edge bundling diagram. This enabled us to see the connections between different bird species more clearly and added an interactive component where if you hover your mouse over one of the bird species, you can actually see the other species that were seen at the same time as this particular bird. This would enable us in the future to develop better predictive analytics about which types of birds you're most likely to see when out in the field. When we were thinking about using our technology in the hands of the end user, we realized we needed a better interface than just clicking around on a website. We use the program API.ai to create a Facebook Messenger bot that enables users to intuitively interact with a chatbot to help them understand what birds they might see in the field. This is a tool that someone can use while actively searching for a bird, and just by putting in the bird species that they've already seen, they can get recommendations on what birds they should look out for.
If we were given the opportunity to take this project further, we feel like we could build a better conversational user interface, which is becoming more common these days. We also feel that better integration could be built with the eBird site. And lastly, we could try to build out more tools for amateurs and scientists alike. But with that, we thank you and wish you happy birding.
No, I didn't get it. Can't do this.